Okay, so we're going to start off by talking about two of the anomalies that get observed in the literature in behavioral economics. The first one is from work by Kahn and Tversky, and the second one is a paradox going back some time called the Allais Paradox. So the first one is the kind of anomaly to do with the disease. Now, what you want to do here is you want to consider an outbreak of a disease that is expected to kill maybe 600 people. You can respond by implementing one of two programs. In program A, 200 people will be saved for sure. In program B, 1/3 probability that you can save 600 people, or 2/3 probability that no people will be saved. So you've seen this before. We surveyed you, and in so doing, we're asking you your opinions on this exact kind of program. And we'll show you those results later in the semester. Now, so this is one choice, right, between program A and program B. Now, what we want to do is you want to contrast that with the similar decision with a slightly different choice though. So program C, here is 400 people will die for sure versus 1/3 probability that no one will die and 2/3 that nobody will be saved. So when you're considering those, program C and program D, which will you choose? So you will ask both of these questions. Choose between program A and program B. Choose between program C and program D. I'm not going to tell you what you guys said just yet. You're going to hear about that later. But when we think about this, what often happens is that when you pair these different program choices and you ask people what they would do, what happens is people will often pick program A and program D, even though what you see is that program A and program C are equivalent and program B and program D are equivalent. Now, what this results in is a contradictory set of choices. Why do people switch? So what we see here is that basically in the first problem, people seem to behave in a risk-averse way. While in the second program, it seems as though people are behaving in a risk-seeking or risk-loving way. Now, of course, just a quick note though, the expected value of the risky option is equal to the safe option in both cases, but this preference reversal, the change in people's behavior, that's inconsistent with expected utility theory. We wouldn't expect people to reverse their behavior in that way if they were behaving consistently with expected utility theory. So why do you think that might happen? Why do you think we see these behavior reversals or these preference reversals? Think to yourself for a moment, because we're going to be dealing with a variety of these anomalies, and it's good to think about what those might look like, or like what your reasons are for why people might change their behavior. We're going to talk about some more of these later in the semester. You'll be talking about them a bit more with Christoph. But just keep in mind that there are reasonable explanations for why people might change. Okay, so here's the next thing that we want to think about. This thing here is the Allais Paradox, named for Maurice Allais. So he's a French economist. So you have a first choice. In that first choice, you have a choice between two prospects, A and B. With A, what happens is you can get £4,000 with a probability of 0.8, or B, £3,000 with probability 1. Okay, so notice in that first choice is basically an implicit 0 with probability 0.2, right? Okay, so 4,000 probability 0.8 versus B, 3,000 with a probability of 1. So that 3,000 is certain, whereas in the first case, A, 4,000 is somewhat risky. There's an 80% chance of getting it. Now compare that with option 2. There you're choosing between C and D. What happens here? With 4,000, you're now getting that with a probability of 0.2, 20%, versus D, where you're getting 3,000 with a probability of 0.25. Okay, so what do people choose? What happens? When you're confronted with choice 1, what do people choose? When you're confronted with choice 2, what do people choose? Well, what we see there is that there is a certain kind of behavior where people behave inconsistently. So many people choose B when confronting the choice between A and B, and then when confronting the choice between C and D, they choose option C. Now, that's going to present a contradiction for us, so let's explain how that works. So if you're choosing between A and B initially, what that implies is that the utility of 3,000 is greater than the what we see with the utility of 0.8, the probability times the utility of 4,000. That must be true by expected, if we're thinking that people are expected utility theory, or behaving consistently with expected utility theory. Now, if it's the case that C is better than D, right? So what is happening there? That means that 0.2, the 20% chance of 4,000, the 0.2 multiplied by the utility of 4,000 must be greater than the 0.25 times the utility of 3,000. So we can see that over here. That's just highlighting what's going on with that inequality. Okay, if you make that choice, it must be the case that the utility of 4,000 times 0.2 is greater than the utility of 3,000 times 0.25. Now here's the problem. What happens if we multiply both sides of that inequality by 4? Well, if we do that, what we get is the utility of 3,000 is less than 0.8 times the utility of 4,000. Now, how does that work? That's directly contradictory. This line here, the utility of 3,000 is less than 0.8 times the utility of 4,000. That contradicts what we said was true if you chose B rather than A. What? Utility of 3,000 greater than 0.8 times the utility of 4,000. So it can't simultaneously be true that the 0.8 times the utility of 4,000 is both at the same time greater than and less than the utility of 3,000. So that's a contradiction. It's inconsistent behavior. And I say that, oh no, transitivity, what's going on? That's just about our idea of consistency, right? So it's not feeding directly into that, but it's something for us to think about here, that the Allais paradox is telling us that there's going to be some kind of inconsistency, and there's a paradox in people's behavior.